I want you to think about the most precise tool you own. For most of us, that's probably our phone, right?
Yeah.
Or maybe a smartwatch.
Yeah, definitely.
We rely on that little clock in the corner for everything, and we just assume it's perfect.
Right.
But what if I told you the device you trust most is actually, fundamentally, running slow? Okay, let's unpack this, because today we are diving into a really fascinating digital paradox.
And it's not a software bug or, a design flaw. It's just a hard engineering reality.
Right.
Our research into digital clock deviation shows that absolute time perfection, it's just not achievable in the electronics we use every day.
So there's a lag.
A subtle, constant lag, and that tiny lag defines the difference between the time on your screen and the absolute scientific standard of time.
And that measurable error, which engineers call clock drift, that's our mission today. We're going to define the gold standard of time, understand exactly how imperfect our devices are, and see why our digital lives need this massive, invisible correction just to stay in sync.
Well, to really get the error, you have to establish the benchmark first.
The gold standard.
Exactly. We're talking about the atomic clock. This is the global standard. Everything that needs hyper precision, think GPS satellites, global financial markets, it's all pegged to this.
So it's basically perfect.
It is unequivocally the most accurate time device humanity has ever created. It's so stable it would take over 30 million years just to lose a single second.
Wow. Okay, now compare that absolute perfection to the little chip in your pocket.
Yeah.
Our source is actually zeroed in on the difference, and the number is, well, it's pretty jaw-dropping.
It is. Your average smartphone clock lags behind the atomic clock by roughly 0.0000001 seconds.
0.6 zeros and a 1.
Let that sink in for a moment. That is 1 part of 10 millionths of a second.
It sounds impossibly small. I mean, it's hard to even wrap your head around a fraction that tiny.
For sure. And practically speaking, if you're coordinating lunch, it is completely meaningless.
Right.
But intellectually, it's profound. That specific measurable gap is the proof. It's the data point that shows the circuitry in your phone is not running on ideal time.
It confirms this constant, unavoidable imperfection.
Exactly, in the way our everyday electronics count time.
Okay, here's where it gets really interesting, because we need to get into the mechanics of that imperfection.
So the technical name for this subtle failure to keep pace is clock drift.
Clock drift.
Yeah, it literally just means a slight deviation in the device's timing. And it happens because of the hardware your phone uses to count time, which is the quartz crystal oscillator.
We hear about crystal timing all the time, but what is that mechanism exactly, and why is it inherently flawed?
So think of it like a tiny, highly tuned tuning fork inside your phone.
Okay.
When you apply electricity to it, it vibrates at this incredibly high fixed frequency, billions of times per second. Your phone is literally just counting those vibrations to figure out how much time has passed.
But I'm guessing the word fixed is the problem here, because the vibration frequency is not perfectly fixed, is it?
No, not at all. It's subject to the real world. It's incredibly sensitive.
To what? Like temperature?
Temperature is a big one. A crystal is actually faster when it's cold, slower when it's hot. It changes if the battery voltage fluctuates, or even under the mechanical stress from the phone heating up and cooling down.
So all these tiny unavoidable things mean the rate your phone is counting seconds is always just a little bit off?
Always slightly slower or slightly faster than the true standard.
So instead of real time, our phones are only capable of producing, I think the source material called it a reduced version of time.
That's a great way to put it. A lighter copy. It's close, but it's internally just a little bit sluggish.
And that sluggishness, that 1 in 10 millionth difference, that's where the problem really starts.
Right, because what's fascinating here is that while the deviation itself is minute, it is crucially cumulative.
Ah, okay. It doesn't just happen once.
It happens every single second. It's constantly building up this debt of lag.
Which raises a big question for you listening. If your phone is constantly adding up this error, what happens over weeks or months? You'd think your phone would just fall completely out of sync eventually.
And that really proves that true technological perfection, especially with something as absolute as time, is still elusive for consumer electronics.
It's a physics problem. You can't just code your way out of it.
Not at all. It's an unavoidable hardware limitation.
So if this clock drift is constantly building up, why don't we notice our clocks falling minutes or even hours behind? My clock seems perfectly synced up with the news.
That is the sheer brilliance of modern infrastructure. The only reason you don't notice the accumulation is because there's a constant external intervention.
It's being corrected.
Constantly. Your phone simply doesn't trust its own internal mechanism for very long.
So how does that correction actually happen? It sounds like the phone is just sort of outsourcing its timekeeping job.
It absolutely is. The source material really emphasizes that our devices rely on crucial external things, primarily the internet and satellites.
And there's a protocol for this, right?
Yes, it's handled through sophisticated protocols like the Network Time Protocol or NTP.
NTP. So that's the unseen hero of our synchronized digital life.
Precisely. Your phone is actively pinging these highly accurate time servers on the internet, and those servers are themselves meticulously synced to an atomic clock.
And they send back the correct time.
They send back a precise timestamp. Your phone gets it, calculates how much drift it's accumulated, and then instantly just snaps its own clock back into line.
It's a continuous microscopic adjustment. Like it's getting a constant software patch for a hardware flaw.
That's a perfect way to describe it. Every few minutes, your device is being told, hey, you've drifted this much, reset.
So this system is the only thing keeping the phone accurate.
The only thing, and you can test this, if we were to take a phone and run it in a complete vacuum, no internet, no GPS.
Like airplane mode, but for real.
Exactly. The sources confirm the drift would just accumulate and the time would lag significantly over time.
If we connect this to the bigger picture then, our reliance on this hidden infrastructure is just staggering.
It really is. Satellites orbiting the Earth, high-speed fiber optics, complex servers,
Right.
all just to maintain the appearance of simple, accurate time on the device in our pocket.
We've completely outsourced the convenience of perfect time to systems we never even see.
It makes you rethink what your phone really is. It's less of a self-contained clock and more of a receiver that's constantly getting updates from the true masters of time.
So what does this all mean for us? Let's zoom out a bit and pull this all together.
Okay.
We established the gold standard, the atomic clock. We quantified the difference, that tiny 0.000000001 seconds. We understood the cause, clock drift, because of the physical imperfection of that quartz crystal.
And we identified the fix, that constant external correction from the internet and satellites.
Right.
And the overarching insight, maybe the most profound realization from the research, is that the time we hold in our hand, it's from moment to moment, not the real time.
It's just always playing catch up. It's like the difference between a really high quality copy and the original master file.
Okay.
And that feels like it goes way beyond just technology. It's almost a philosophical point about our reality.
It is. Our whole everyday reality, coordinating flights, financial transactions, everything is constantly being tweaked and corrected by these invisible, hyper-accurate systems. We perceive perfection only because the correction mechanisms are so much more powerful than the devices we actually touch.
It's a beautifully managed illusion of precision.
It is.
Your phone is a fantastic device, but it's fundamentally a drifting clock that's kept honest by this entire global infrastructure, all designed to manage these tiny, tiny errors.
And that leads us to the final, I think, provocative thought. If the only thing distinguishing real time from this reduced version is that tiny error and the massive system that manages it, how much of our perceived digital reality is actually just another perfectly managed illusion?
What other absolute facts of our lives are subtly untrue, only held in place by invisible systems working just out of sight? That's something worth mulling over next time you check the time.
Thank you for joining us on this deep dive into the secret imperfection of your digital clock.
We'll catch you next time.